Discover Geography, Lesson 7-5, Solutions to Climate Change. In this lesson, we'll be talking about some of the specific things that we might do to try to offset anthropogenic climate change. In order to offset anthropogenic climate change, we need to reduce the amount of greenhouse gases that are trapping the sun's heat on the Earth. And to do that, we need to not just decrease the amount of greenhouse gases that we're emitting, but we need to actually bend our trajectory of greenhouse gas emissions downward. Right now, we're not only emitting too many greenhouse gases, but we're emitting increasing amounts of greenhouse gases each year. And so this has led some climate scientists to propose the concept of a climate stabilization wedge. A wedge is essentially a change in our trajectory of greenhouse gas emissions that avoids 1 billion tons of carbon emissions over the next 50 years. So in essence, if we accomplish a wedge, we've bent that trajectory downward. We've slowed our rate of increasing greenhouse gas emissions. And they estimate that we need about 7 wedges in order to stabilize our carbon dioxide emissions and therefore to stabilize our climate. When we're thinking about where we want to stabilize our greenhouse gases in the atmosphere, there are a variety of potential target levels of CO2 in the atmosphere. These are generally measured in parts per million of carbon in the atmosphere. You can see from the diagrams that the amount of carbon dioxide in the atmosphere has varied at various points throughout recent geological history, but has taken a dramatic upward turn since the Industrial Revolution. Prior to the Industrial Revolution, the concentration of CO2 in the atmosphere was about 280 parts per million. That has risen to the point that now we have about 400 parts per million of CO2 in the atmosphere. That is, we've added about 30% to our concentration of CO2 in the atmosphere. So what level of CO2 should we aim at? Well, that is in part a policy choice as much as a scientific choice. Climate science can try to tell us what are the effects on our environment of a certain concentration of CO2 in the atmosphere over a certain time period. But climate science can't tell us which of those effects are worth accepting and which of them are worth the cost of avoiding. So obviously a higher level of CO2 in the atmosphere is going to create more of those effects we talked about in our climate change lesson. Increased number of hot days, increased droughts, increased sea level rise, etc. But any measures to reduce climate change will have, at least in the short term, some sort of costs. And so it's a political choice as to what costs are worth it for what kind of impacts on our climate. The 2 targets you'll most often hear talked about are, first, 450 parts per million. That's the common political target. If you listen to politicians, especially in international negotiations about climate change, that's the number you'll usually hear from them, that we want to cap our atmospheric concentration of CO2 at 450 parts per million. Now, if we're at 400 right now, that doesn't give us a lot of leeway. That doesn't give us a lot of room to increase our CO2 emissions before we hit that cap. So capping our CO2 concentrations at 450 parts per million is a pretty ambitious goal. It would take some pretty significant changes in our economic systems in order to reduce emissions enough to hit that target. However, some people argue that even that target, even as ambitious as it is still too high, that the impacts that we would suffer from climate change at that level are more severe than we ought to be willing to accept. And so you often hear climate change activists citing the number 350 parts per million as the desirable long-term cap on CO2 concentrations in the atmosphere. Now you'll notice we've already gone past that. Hitting 350 parts per million would require us not only to level out our anthropogenic emissions, but actually to reduce them and to draw some carbon dioxide back out of the atmosphere, to reduce our CO2 concentrations back down to 350 parts per million. So that's an even more ambitious target. But climate change activists will argue that it's a necessary target in order to avoid really undesirable sorts of impacts from climate change. in order to deal with climate change requires some sort of global cooperation. One country cannot solve climate change on its own because we have one global climate system. With some environmental problems, different countries could pursue different strategies. So the United States, for example, could decide that it's not worth it to clean up our rivers, and we could just decide to live with really polluted rivers. Meanwhile, another country, let's say Germany, could decide that clean rivers are really important to them, and they're going to make sure to clean up their rivers. And so we could go forward with the United States having really dirty rivers and Germany having really clean rivers. That's possible because the rivers in the United States are different from the rivers in Germany. However, the United States and Germany and all other countries share the same global climate system. So if the United States emits a ton of carbon dioxide, that's going to have the same impact on the global climate as Germany emitting a ton of carbon dioxide. The effects of that CO2 will be felt by both countries, regardless of where those emissions take place. So that suggests that we need some sort of global cooperation to reduce our overall greenhouse gas emissions. The other complication on global cooperation is that different countries' contribution to climate change and different countries' level of suffering from climate change may be very different. You see in this picture greenhouse gas emissions per capita. So some countries, such as the United States and Australia, are emitting a huge amount of greenhouse gases per capita. Other countries, like most of Africa, are emitting very little greenhouse gas emissions per capita. So therefore, if as a world we're going to reduce our emissions, that's going to require much bigger cuts from the United States, Australia, Europe, etc., than it would from, say, Africa or Latin America. Further complicating this picture is the question of historical emissions. The amount of CO2 in our atmosphere is a function not just of what's being emitted this year, but what's been emitted in all past years. When carbon dioxide gets emitted into the atmosphere, it's going to stay there for a long time. So the warming we're experiencing now is the result not just of current emissions, but of historical emissions. So here's a chart of historical greenhouse gas emissions. And what you can see there is that the United States has historically been by far the largest emitter of greenhouse gases. The United States was one of the early countries to industrialize, and we know that greenhouse gas emissions are closely linked with industrialization. And so as our economy has grown, our greenhouse gas emissions have grown. You may notice a small dip in the US section of that chart right in the 1930s. When our economy went down as a result of the Great Depression, our greenhouse gas emissions went down. When our economy recovered after World War II, our greenhouse emissions went back up. The next section of the chart is the former USSR, the former Soviet Union. And you can see, starting around World War II, when that country began to industrialize to a great degree, their emissions began to grow rapidly. At the time of the fall of the Soviet Union in 1991, where you can see the one block for the Soviet Union splitting into separate blocks for the constituent countries, there was a major economic collapse in that area, and so you can correspondingly see the greenhouse gas emissions going down. But the Soviet Union has historically made a pretty substantial contribution to climate change, even though its current emissions of the countries that are successor to the Soviet Union, are smaller than they've been in the past. Next up, you notice China. China had very low emissions for a very long time. It wasn't until the 1970s that China started to industrialize on a large scale. And at that point, you can see Chinese emissions growing by quite a bit, to the point that as of the last few years, China actually emits more total greenhouse gases than the United States. If you total up the total amount of CO2 emitted this year in the United States and the total amount emitted this year in China, China is actually ahead of the United States. Now, China has lower per capita emissions, because while they may have slightly higher total emissions, they also have far more people to divide those among. So the per capita emissions are still much below the United States. And China's historical emissions are still much below those of the United States. So China hasn't emitted as much over time. They've only very recently hit these high levels of emissions, whereas the United States has been a high emitter for a long time. These kind of differences have proven to be a major issue in negotiating international agreements about reducing climate change. Which countries ought to take the largest responsibility for reducing greenhouse gas emissions? On the one hand, poorer countries, such as China, make the argument that because rich countries like the United States are responsible for such a large amount of historical emissions, so therefore they are responsible for such a large amount of the actual warming going on, and because rich countries have had the opportunity to gain wealth through emitting greenhouse gases, because as we've seen, greenhouse gas emissions tend to rise and fall with the state of the economy. Therefore, it's on those richer countries to make the biggest sacrifices, because they can afford it and they're most responsible for the problem thus far. On the other hand, the United States usually would argue that developing countries like China have a responsibility to make big cuts as well, because their current levels of emissions are very high. And if they continue on their current trajectory, their increase in emissions is going to swamp any reductions that the United States might make. And so the climate will still continue to change. It's for this reason, due to this disagreement, that the United States never signed the Kyoto Protocol, which is the one major global treaty that set specific targets for what sorts of emissions reductions different countries should make. The Kyoto Protocol basically accepted that argument that I was describing as being the Chinese argument. The argument that the rich countries, because they're historically responsible for more emissions and because they're richer and more able to afford it as a result of their past emissions creating activity, ought to be the ones to reduce their emissions by more. Other countries that are poorer did not have strict caps on their emissions under the Kyoto Protocol. So the Kyoto Protocol only required emissions reductions from the richer countries, the so-called Annex I countries. When this treaty was brought back to the United States Senate for ratification, the Senate voted 95-0 to reject it because it did not include required emissions reductions from developing countries like China and India. And this has been a major issue for the United States under both Republican and Democratic administrations with any further negotiation of climate change treaties. Now, the Kyoto Protocol expired at the end of 2012. Its emissions reductions targets were spelled out through the end of that particular year. So the Kyoto Protocol is no longer a live issue. No successor agreement has been negotiated thus far. So right now there is no global treaty giving specific greenhouse gas reduction targets for countries around the world. But the various countries of the world still meet annually to try to hash out some sort of agreement that can combine the interests and the responsibilities of all the different countries of the world who are in very different positions in terms of the impact on their country from climate change and their current and historical greenhouse gas emissions. Now, if a country decides to reduce its greenhouse gas emissions, whether on its own because it's just concerned about climate change and wants to make some difference, or as the result of some sort of binding commitment from a treaty like the Kyoto Protocol, there are a variety of general approaches that they might take. One such approach is known as a carbon tax. A carbon tax, sometimes known as a carbon price, is a rule that requires people who emit greenhouse gas emissions to pay a fee for those emissions. So as an example, Australia recently instituted a carbon price policy. Under the Australian policy, any large company that wanted to emit greenhouse gas emissions had to pay $23 per ton of carbon that they emitted. This is essentially buying a permit to emit 1 ton of carbon for $23. A company under a carbon price system can buy as many permits as they want, as long as they're willing to pay the price for those. So the idea is that having to pay that price for all the emissions that you emit creates a disincentive to emit them. If a company can find a cheaper way to reduce its emissions, that will be better for its bottom line than having to pay this tax, than having to buy all these permits to allow it to emit that carbon. So this is employing a market type of mechanism, creating an economic disincentive for emissions. A related policy to a carbon tax is what's known as cap and trade, or emissions trading. Under a cap and trade system, the government sets a strict limit on how many emissions permits will be allocated. So you can't get as many permits as you might like. There's a strict limit on how many will be issued. However, you can buy and sell those permits between different emitters. So if one company wants to emit more carbon dioxide in a given year, they can try to buy that permit from another company that doesn't need it right now. So this creates an incentive to reduce your emissions so that you don't have to go looking for other people's permits to buy and paying for them. And so that if you reduce your emissions below what you have permits for, you can then make money by selling those extra permits to somebody else. The Australian system was designed to transition from a carbon price in the introductory years into an emissions trading scheme, in which Australia will be integrated with the existing emissions trading scheme in the European Union. Now, in this case, the European Union has issued so many permits that they're currently selling for only $6 a ton. So those permits have gotten very cheap because there are a lot of them on the market as compared to the amount of demand for them. But in theory, if the number of permits was restricted more, then the price would go up because they would be harder to get. People would outbid each other to try to get those permits. So in the emissions trading scheme, the same basic type of economic incentive is driving companies to reduce their amount of carbon emissions because they don't want to have to pay for making those emissions. It's simply a matter of whether you fix the price and let the amount vary, or you fix the amount and let the price vary, depending on whether you're instituting a carbon tax or a cap and trade system. Another approach you might take is a regulatory mandate. In this case, the government, rather than creating this economic incentive to figure out how to reduce your emissions, spells out a particular way that emissions should be reduced and requires all emitters to meet these standards. So one good example of a regulatory mandate is the Corporate Average Fuel Economy Standards, or CAFE standards, in the United States. The CAFE standards are a system under which the US government sets an average fuel economy, that is an average number of miles per gallon, that all the cars sold by a particular car manufacturer must meet. And this miles per gallon standard is set to decrease every year. That is, companies are required to make their vehicles more and more efficient over time, to use less and less gas per mile, and therefore to emit less and less carbon dioxide from burning that gas. So here, the government is requiring companies to meet a particular standard for reducing their greenhouse gas emissions. And finally, the policy may involve giving subsidies and incentives to people who adopt certain emissions reductions measures. So for example, many places offer subsidies for homeowners who install solar panels. Solar panels can be a big expense up front to install, even though they tend to pay for themselves in the long run by giving you free energy from the sun, especially if you live in a very sunny area. And so many governments will offer incentives and subsidies to help people install these solar panels to make them more likely to do this, which will then have the effect of reducing greenhouse gas emissions because they're not drawing on power that's supplied by an oil power plant or a coal-fired power plant. Finally, we could have a system in which the government is out of the picture entirely, and in which we rely on the private sector to incentivize reducing our emissions. So in this case, we may look on the one hand to non-governmental organizations, activist groups, to encourage people to voluntarily reduce their emissions. So we have groups like 350.org or Union of Concerned Scientists, that if you go to their websites, they'll have a whole lot of information about what you could do to reduce your own personal emissions. Now, these groups often also advocate for governmental policy changes, but they're also suggesting that individual voluntary changes can have a significant impact on reducing our greenhouse gas emissions. On the other hand, we have for-profit companies. Various companies have found that there are ways to make money by doing things that reduce our greenhouse gas emissions. So we have, on the one hand, companies like TerraPass that sell offsets. That is, these companies will take on various projects that reduce the CO2 in the atmosphere. So they might plant a whole bunch of trees in an area that's been deforested so that those trees draw carbon out of the atmosphere as part of the carbon cycle. Or they may invest in research that develops new, more energy efficient technologies. then they sell what are called offsets to consumers. So if you're going to be driving your car around emitting greenhouse gases, and you feel bad about that, you might pay TerraPass for offsets equivalent to the amount of gas that you're burning in your car. So yes, you're emitting these greenhouse gases, but you're paying TerraPass to do something that will reduce greenhouse gases in an equivalent amount. And so they're making a profit off of selling this to willing consumers. You also have green energy companies like Green Mountain Energy that's listed there. They found that they can make a profit by marketing themselves to consumers as an energy source that isn't causing climate change. They can say, we get all our energy from wind power or solar power or some other clean source, and so therefore you should buy our energy and not energy from some company that's using a coal-fired power plant. So these for-profit companies can do certain things that end up reducing our overall society's emissions of greenhouse gases. So let's say we've decided that we need to reduce our greenhouse gas emissions, whether it's because we are facing a regulatory mandate or because we don't want to have to pay so much carbon tax or because we see a good opportunity to make a profit off doing this, or we just want to voluntarily do it because we want to feel like good people or whatever. What exactly might we do to reduce our overall greenhouse gas emissions? Well, one thing we can do is to try to increase energy efficiency. We can try to get the same level of benefits while using up less energy and using up less materials and therefore emitting fewer greenhouse gases. So if we do something like changing from a conventional car to a hybrid car, we can do the same amount of driving but with a lot less greenhouse gas emissions. If we switch from conventional incandescent bulbs to compact fluorescent bulbs, we're going to use a lot less energy and therefore going to cause a lot less greenhouse gas emissions. And there are a variety of technologies that have been developed that aim to increase our energy efficiency. Another thing we can do, because energy is a major source of greenhouse gas emissions, is that we can find alternative forms of energy that don't generate greenhouse gases. And you see a variety of these on the slide here. We have hydroelectric power from dams. We have tidal power from turbines turned by the tides going in and out. We have wind energy. We have ethanol. We have biomass energy, which is basically burning wood chips. We have nuclear power. We have solar power. We have natural gas. We have geothermal power that's based on the heat from the asthenosphere within the Earth. Now, some of these have small emissions. Natural gas still emits some level of emissions. Biomass energy has some emissions. Ethanol has some emissions, but they're less than conventional forms of energy. Now, no one of these alternative energy sources is obviously the best and should be the one energy source we switch over to. They all have their pluses and minuses. Natural gas still emits some emissions, and there are concerns about the environmental impacts of some of the drilling techniques. Geothermal power is only available in certain areas where you can easily drill down to the asthenosphere. Nuclear power has great concerns about disposal of the nuclear waste. Hydroelectric power blocks the flow of rivers and disrupts the ecology. So any of these energy sources have their downsides, but some combination of them could replace our high emissions energy sources and therefore reduce our total emissions. Another thing we might do is to directly remove carbon from the atmosphere and store it away somewhere. So this is a system called carbon storage. Usually what a carbon storage system proposes to do is to have some sort of facility that takes in carbon dioxide and then pumps that carbon dioxide down into crevices under the earth, often into old coal or oil beds where the fossil fuels have been removed, and so now we can fill that up with CO2 taken out of the atmosphere. We can basically take all that carbon that we pulled out when we mined those fossil fuels and put it back down there, out of the way. Another thing we might do is alter our land use. Land use change is a major contributor to climate change. Our agricultural techniques often generate a lot of emissions. And so on the one hand, we can change farming techniques. Things like no-till farming greatly reduce the amount of carbon emissions that are given off by those farms. We can also change what kind of agriculture we're doing. Raising livestock creates a particularly large amount of emissions. Because not only does raising livestock usually require a huge amount of plant agriculture to feed those livestock, and we talked about that ratio of energy that's lost if you eat one step higher up on the food chain, but livestock are often the sources of greenhouse gases directly. And this is what's being referred to when people talk about things like cow farts and sheep burps as causes of climate change. Livestock flatulence produces methane, which is a major greenhouse gas. And so if we were to change our diet to eat less meat, more vegetarian foods, and you see in the picture there some tempeh and broccoli pasta, that would be a nice vegetarian meal, that would reduce our amount of greenhouse gas emissions. We might also think about reducing our population. If you think back to the iPad equation, population was one component of what is responsible for our impact on the environment. And of course, climate change is one serious impact on our environment. And so there are people who are choosing to have fewer children because they're worried about the environmental impact of those children. And one online environmentalist website came up with the cutesy acronym GINK, Green Inclinations No Kids, to describe people who choose not to have children or choose to have fewer children out of concern for the environment. Other people advocate population control policies, things like promoting birth control in countries with high rates of population growth as a way to reduce those countries' population and therefore to reduce the amount of carbon emissions that they're responsible for. And finally, we have the idea of geoengineering. Geoengineering refers to techniques to deliberately modify the Earth's climate in ways that offset the effects of climate change. Many of these geoengineering systems involve putting things into the upper atmosphere that will reflect away part of the sun's light. So the system that you see described here, we have a balloon with a pipe that goes down to the ocean, and it's sucking up salt water and spraying that salt water into the upper atmosphere. And so that cloud of salt water in the upper atmosphere is going to reflect away the sun's light. And so less solar energy will get through to be trapped by our greenhouse gases. Other systems have suggested doing this with tiny mirrors in space. A geoengineering proposal is bound to be extremely controversial. There's research going on into geoengineering, and some people believe that that's very important as a potential last-ditch effort to save our climate. That all of our policies for potentially reducing emissions enough to stay within a reasonable target amount of greenhouse gases in our atmosphere are not going to be enough, that we're unlikely to actually achieve those solutions, and so we need geoengineering as kind of a last-ditch effort. Other people point out that geoengineering, because its continued interference with the Earth's climate system, could have all kinds of unforeseen consequences. It could create all kinds of additional environmental problems, even if it does help to offset climate change. So geoengineering remains a highly controversial policy to deal with climate change, but it is one that gets a lot of discussion.